Hi, welcome to part 3 of alternating current. In this video, I shall explain the solution of question number 7.3 given in page 266 of NCERT Physics textbook for class 12, part 1. The question says a 44 millihenry inductor is connected to 220 volts 50 hertz AC supply. Determine the RMS value of the current in the circuit. This is a simple question. We can simply use the formula and do the sum. But I would like to explain, exactly why we are using this formula. So we consider a circuit with an AC voltage source connected to a pure inductor L. So what happens? This is a time dependent voltage source. So we can write this as Vm sine omega t. Now, according to Kirchhoff's loop law, the sigma EMF of a circuit is equal to 0. Because of the inductor here, we have self-induced Faraday's EMF across the inductor. So, the total voltage is V minus L di dt. This is the self-induced Faraday's EMF. The minus sign is because of the Lenz's law. This is equal to 0. So V becomes equal to L di dt. This is also, since V is equal to Vm sine omega t, we can write this equal to Vm sine omega t. Now, di dt could also be written as Vm by L sine omega t. So we have di by dt equal to Vm by L sine omega t. So this we can write it as di is equal to Vm by L sine omega t dt. Now we can integrate both sides. On integration we get I is equal to Vm by L omega minus cos omega t plus an integration constant. Since the voltage source is time dependent, current will also be time dependent. So this constant shows that there is a part of current which is not dependent on time. So since the voltage is dependent on time, the current is also dependent on time. So there cannot be any time independent part of current. So C has to be equal to 0. So I becomes equal to minus Vm omega L cos omega t. So I is written as minus Vm omega L cos omega t. So V is written as Vm sine omega t. If we have to compare the phases of the source voltage and the induced current produced in the circuit, we need to have both of them in the form of sine. Only then we can compare their phases. So we need to compare minus cos omega t into sine. We know that omega L can also be, because cos theta is also equal to sine pi by 2 minus theta. So cos omega t can also be written as sine pi by 2 minus omega t. Now we take the sine of minus sine theta is also equal to minus sine theta, minus sine theta is also equal to sine of minus theta. So we take the minus inside and we get Vm by omega L sine of omega t minus pi by 2. So if we compare this with the source voltage, we see it is equal to V is equal to Vm sine omega t. So current is 90 degrees. If you compare the angles of omega t minus pi by 2 with omega t, you see that current is 90 degrees behind voltage. So I could also be written as Im sine omega t minus pi by 2, because when this part is equal to 1, I gets its maximum value. So Im is also equal to Vm by omega L. Vm by omega, this part is written as Im sine omega t minus pi by 2. So Im is also equal to Vm by omega L. Im is also equal to Vm by omega L. If you divide Im by root 2 and Vm also by root 2, then we can get the same thing in the form of IRMS is equal to VRMS omega L. So coming back to the question, VRMS is given as 220 volts. So IRMS would be equal to 220 divided by omega is given as 2 pi into 50 into L is given as 220. L is given as 44 into 10 to the power minus 3. So this we get as 15.92 amperes. It's not writing over here. So 15.92 amperes. In case of any doubts or clarifications, please log on to www.olympiadtester.com/mentor. Thank you.